In this session, let us learn about SciPy spatial data. Working with spatial data. Spatial data refers to data that is represented in a geometric space. Example, points on a coordinate system. We deal with spatial data problems on many tasks. Example, finding if a point is inside a boundary or not. SciPy provides us with the module SciPy.spatial, which has function for working with spatial data. Triangulation. The triangulation of polygon is to divide the polygon into multiple triangles with which we can compute an area of the polygon. A triangulation with points means creating surface composite triangles in which all of the given points are on at least one vertex of any triangle in the surface. One method to generate these triangulations through points is the Delaunay method triangulation. See the example, create a triangulation from the following points. See 2 4 3 4 3 0 2 2 4 4 1. By using Delaunay points method, the result returns this. Convex hull. A convex hull is the smallest polygon that covers all of the given points. Use the convex hull method to create a convex hull. Create a convex hull for following points. By using convex hull method, the result returns this. KD trees. KD trees are data structure optimized for nearest neighbor queries. Example, in set of points using KD trees, we can efficiently ask which points are nearest to a certain given point. The KD tree method returns a KD tree object. The query method returns the distance to the nearest neighbor and the location of the neighbors. Find the nearest neighbor to point 1 1. See the result. If we write the code and execute this by using KD tree points, the result is 2.00. Distance matrix. There are many distance matrices used to find various types of distances between 2 points in data science. Euclidean distance, cosine distance, etc. The distance between two vectors may not only be the length of straight line between them, it can also be angle between them from origin or number of unit steps required, etc. Many of the machine learning algorithms performance depends greatly on distance matrices. Example, k nearest neighbors or k means, etc. Let us look at some of the distance matrix. Euclidean distance. Find the Euclidean distance between given points. From SciPy.spatial distance import Euclidean. See, by executing this code, the result is 9.21954445729. City block distance, Manhattan distance, is the distance computed using 4 degrees of movement. Example, we can only move up, down, right or left, not diagonally. Find the city block distance between given points. See here, by executing this code, importing city block, the result is 11. Cosine distance is the value of cosine angle between the 2 points A and B. Find the cosine distance between given points. See, by using important cosine and executing this, the result is 0.0194193243091. Hamming distance is the proportion of bits where 2 bits are differences. It is a way to measure distance for binary sequence. Find the Hamming distance between given points. From SciPy.spatial distance import Hamming and execute this code. By executing this code, the result returns is 0.666 something 7. Okay friends, this is the end of part 6 SciPy spatial data. In next video, let us learn about another topic, SciPy MATLAB arrays. If you like our program, please like, subscribe and press bell icon for our next part video updates. Thank you friends. Meet you in next video. All the best.